Hello, can you hear me? Hello, can you hear me? Hello, can you hear me now? Hello, can you hear me? Hello. Hello, can you hear me now? Okay.
Assalamu alaikum, sir.
Walaikum assalam. Can you hear me?
Yes, sir.
Okay.
Alright.
Okay. So I share my screen. Can you see my screen now?
Yes, sir.
Okay. Hi and welcome to the 3 days advanced course level 1 on Google Earth Engine. So I am course coordinator and this course will be taken for the 3 days, and in these 3 days I also try to discuss some advanced level so that you can easily work with the Google Earth Engine platform. And we already finished our beginners course, okay, and this course also this knowledge also need in here, okay. So in this course content I will try to discuss about the all of the course content, and I also try to, you can see, first of all I also try to discuss about the spectral indices and develop the skill for calculating any index, okay. Then move to the visualization, the DEM, okay, of hillshade map and solve map using the Google Earth Engine platform. So mainly here I use the NASA SRTM dataset. Then I also try to show you that Google Earth Engine how to make the NDVI chart over period of time, and then move to the air quality monitoring. So in this time I also try to show you that how you can easily work with the air quality monitoring and how you can also download the air quality monitoring data, okay, and also make the time series chart analysis in here, okay. And we also mainly in this advanced course I also focus in the land cover classification map, okay. So mainly in this course I also try to show you the all of the classifier in Google Earth Engine platform, how you can easily work with this all of the classifier for making the land cover classification map, and how you can easily make the land cover classification calculated the every feature area, okay. Then how you can easily make the land cover classification map with their accuracy assessment, okay. And also how you can easily add the legend and title, okay, then scale bar, okay, and finally calculating the LULC map in your Google Earth Engine platform. So in this time in this course I also add you your specific area, which area you just send me the shape file. We also work with this area so that you can also learn this, as well as also you can complete your research work or thesis work, okay.
Thank you, sir.
Okay. So first of all, first day course content will be that in this time I also try to discuss about the spectral indices and develop the skill for calculating any index using the Google Earth Engine platform, and then how to remove cloud from satellite images, okay. So when you work with the different type of satellite imagery, just Landsat or Sentinel, then you can see here the some cloud and haze in your satellite image. So it's a very difficult for when you want to make the land cover classification map and your satellite image has some cloud, okay, then you cannot get the proper result. So that's why I also try to teach you that how you can easily remove the cloud and haze from your satellite images, and you can get the clear image, and then you can easily work with the make the making map of land cover classification or other in remote sensing work, okay. So then I also try to discuss about the visualization DEM of hillshade map and solve map. So how you can easily make the visualization, the digital elevation model DEM of hillshade map and solve map using the Google Earth Engine platform. Here I mainly use the NASA SRTM dataset. Then make a NDVI chart over a period of time, how we can easily do this. And then air quality monitoring. So mainly in this time and the in here I also try to show you that how you can monitor the sulfur dioxide and nitrogen dioxide, and after this how you can easily get the data, okay, how you can easily get the every data, okay, or time series analysis data from here, okay. Okay, let's start. So first of all, spectral indices develop the skill for the calculating any indices, okay. So first of all, what is spectral indices? So you can easily say that spectral indices are combination. Spectral indices are combination.
Recording in progress.
Spectral indices are combination of spectral reflectance from two or more wavelengths that indicate the relative abundance of the feature of interest, okay. So mainly when you work with the spectral indices, here the two or more band wavelength that indicate the abundance of feature of interest, okay. Suppose we can say that and types of spectral indices, there are the different types of spectral indices, okay. Suppose NDVI, you can also say the NDWI, then EVI, then VCI, and lot of indices, spectral indices we can add here. And then vegetation, you can see vegetation indices. So mainly we can easily use the vegetation indices for identify the vegetation, okay. So mainly we can use here the NDVI, this is the normalized difference index, or EVI for enhanced vegetation index, okay. So for the identify the vegetation, okay. You can also say that another index is the water indices. So water indices, we can also say that this is the NDWI. NDWI is that normalized difference water index, okay. For using the monitor the water in a surface, we can use the water indices. Then build up indices, okay. So it called the build up indices. We can also use here the build up indices for making the build up for identify the build up area or man-made area, okay. If you want, you can also use here the geological indices, okay. So different types of indices such as this is the geological indices. We can easily identify the different types of geological feature using these indices, okay. And this is the another for the burned area indices, okay. Suppose when you using these indices, then you can easily get the burned area, okay. You can also use here the enhanced vegetation indices. Actually lot of indices will be available, and spectral indices are the combination of spectral reflectance from two or more wavelengths that indicate the relative abundance of the feature of interest. So we can easily calculate all of the indices. We can easily calculate all of the indices in our Google Earth Engine platform, and we can easily identify this is the vegetation, this is the water, this is the build up area, this is the geological indices, this is the burn area, this is the NDVI. We can easily identify all of the feature, okay, using the spectral indices, okay. So then suppose calculating any index. So when you want to calculate the index, first of all you need to know what's the formula of this index, okay. Suppose you want to work with the formula is that NDVI, okay. Suppose we already know about the NDVI formula is that near subtract with red divided by near plus red, okay. This is the equation, okay. When you want to work with the Google Earth Engine platform for calculating the indices, we can use here the three method, okay. First method is that you can directly put your equation, okay. You can directly put your equation, and another method is that you can use the expression function, okay. This is the another method. If you want, you can also use here the function, okay, for calculating any indices. So this is the three different way we can easily calculate it all of the indices. If you want, you can just put your equation, or if you want, you can just use the expression function, or if you want, you can just use a function, okay. And now I will explain all of the one by one in the code editor so that you can easily understand, okay. So I simply open my code editor and practically show you that, okay. Suppose you can see this is the NDVI and NDVI equation. So here I use the two indices, normalized difference vegetation index and normalized defines build up index. So you can see this is the equation, okay, for NDVI, near band minus red band divided by near plus red band. Okay, so now you can just using this equation in your Google Earth Engine platform and you can get this result, and we can put this equation in the three different way. What is the different way? You can see, if you want you can use the directly equation, okay, just this is our equation, I put this equation directly, so this is the one way. And if you want you can use here the expression function, so this is the another way, and this is the another way for using the function. Okay, so I will try to show you all of the things one by one so that I hope you can easily understand. Okay, so let's start. So I open my code editor and try to show you the all of the part one by one. Suppose first of all, suppose I want to calculate the indices for NDVI, and we follow all of the process so that you can easily understand. So suppose first of all I want to make the NDVI for using the Sentinel-2 satellite imagery. Okay, so I simply search in here the Sentinel imagery. Suppose I simply search here the Sentinel-2. Okay, so here I can get this data set. So I simply use here the level 1C, this data set, multi-spectral instrument level 1C. This is my data set. Okay, so I just simply click on the import. And this data set will be imported in my code editor. And you can see this is the default variable name is the image collection. I just change this name. Suppose in this time I simply use here the Sentinel-2. Okay, I just simply use this variable name. Okay, so now my image collection will be added in the code import in the code editor. And now I also simply select a place. Suppose I want to calculate the NDVI for this place, so I simply get this marker and I simply put this name is that, suppose this is my RY, region of interest. Okay, so now I want to calculate this NDVI. Okay, so first of all I simply suppose I want to filter this image collection, and we already discussed about the all of the part in our beginner session, so that how we can easily filter this image collection. So first of all I simply take a variable and give this variable name is the selection. Okay, and then I call my whole collection is the Sentinel-2. I simply use here the Sentinel-2, and then I simply use here the filter bounds function. Okay, so filter bounds, it will be intersecting with my collection with my region of interest or RY. So I simply use here the RY. Okay, and then suppose I want to calculate this filter data. Suppose I want to get the data between this time period, so I simply use here the filter date function, and then I just simply put here the date, specific date for the year of 2015. So 07. Suppose I say randomly put this date. Okay, this is my observation date, and I also put here the this date is that 2017. Then I simply put here the 09 and use here the 30. Okay, so this is my observation date, and I also use here the short function. So I simply use here the short, and short, so it is a short array ms to the short. So here I shortcut to filter a collection by intersecting with RY. So here I use the filter bounds function, and filter date function, it will be just I just get here my observation time period, and short, in this time I want to use this short, it is the array image to short. So suppose in this time I simply use here this image properties. So this image properties is that cloud average assessment. I simply use this. Okay, I simply use this and just paste here, and after this I simply use here the first function. So it will be shorting and get the first image. Okay, so I simply use here the first, and if you want to get the information about this image, so I simply use here the print function, and then I simply call the selection. Okay, then I simply click to the run. So now you can get here this result under the console tab. So here you can see this image will be captured at the time, you can see between this time period 2016 first 18 January. Okay, we can get this image. Okay, this image will be captured, and here you can see this image has a total 16 bands. Okay, okay, you can see all of the bands. Also you can see this is the properties. Properties is that you can see cloud pixel percentage 0, cloud coverage assessment 0. So it means that I can get here the I short this image using the cloud coverage assessment, and here short is the array image to short and get the first image. Okay, so I can get here the totally, you can see cloud pixel percentage 0 and cloud coverage percentage will be 0. Okay, so this is my image, and now I want to, suppose I want to show this result. Okay, I want to show this image in my area. So for this I want to use here the true color composite. Okay, suppose I want to, first of all I want to show this image in the true color composite. Okay, so if you want, okay, suppose I simply take a dictionary. So when you want to make the dictionary, and we already said that in our beginner session, when you want to make the dictionary, you just use here the curly bracket. Okay, and then you just put your keyword and key value. Okay, suppose in this time I simply use here my this keyword is that I simply put here the bands. Okay, I simply put here the bands, and I want to make the list of the band, so I simply use here the square bracket. So when you want to make the list, you use here the square bracket, and when you want to make the dictionary, you use here the curly bracket. So in this time, so bands, I want to show this band. Suppose this band is the B4 red band, B3 green band, and then B2 okay blue band. I want to show this band. Okay, so this is my one keyword. Okay, this is my keyword and this is my key value. I just use this key value, and after this I want to show another is the mean. Suppose I want to show the mean pixel, mean reflectance. It will be start from the 0, and max, I simply use here the max, it will be 3000. Okay, okay, I just put this, and this is my dictionary, and I store this dictionary in a variable. So I simply use a variable is that I simply use the variable and give this variable name is the true color. Okay, and store this. Here you can see I just make a dictionary, and in this dictionary I just simply put here the keyword is the bands, and under this keyword I just make a list of the band, which band I want to show in my area, and I also select here the mean and max. Okay, pixel value. Okay, so now I want to show this. So I already discussed about this in our beginner session. You can simply use here the map dot add layer function. Okay, and here you can get all of the argument. Okay, so in this time I want to show this collection selection. Okay, so I simply copy this and paste here. Okay, and then true color. So this is my visualization. Okay, so here you can see this is my visualization, and in this visualization parameter I want to show here the B4, B3 and B2, and then I simply use here the mean pixel value and max pixel value up to 3000. Okay, so that's why I simply copy this visualization parameter and paste here. Okay, after this name, suppose in this time I just put this name is the true color. Okay, true color, and shown, and opacity not needed for this time, I simply remove. Okay, so now it will be added with my code. So I simply click to the run. So now I can get this result. You can see I can get this image. Okay, you can see I can get these images. Okay, and it's showing the true color composite because here I use the true color combination. Okay, true color band combination. Okay, suppose you want to show the false color composite. Okay, so you want to show here the false color composite, it also possible. So just I simply I take the another variable is that suppose this is the true color composite, it will be showing the true color, and in this time I also want to show here the false color. So I simply take the variable, and then I simply use here the variable name is the false color. Okay, and I want to make a dictionary, so I simply use here the curly bracket, and between this curly bracket first of all I select my bands. So I simply use the bands and simply make a list of the band. Suppose in this time false color, when you want to work with the false color, so you need to use here the near infrared band B8, and then you put here the B4 red band. Okay, and then you need to also work with the blue band P3. Okay, and you can get all of the band information in your information sheet. Here you can see all of the band information you can use here. We can easily use all of the band, and we can use the any band combination, true color composite, false color composite, or any other combination. You can easily create this. Okay, so here you can see I just use this band name, and after this I just use here the mean pixel value. It will be start from the 0, and I also define here the max pixel value up to 3000. Okay, so now I want to show this result. I simply use here the map dot add layer. Okay, and then I simply call my collection selection. Okay, this is my full collection. I just call it, and then I paste here. This is my object name, and then my visual parameter is the false color. I simply copy this visual parameter and then paste here. After this I simply put here the layer name is that false color. Okay, so then I simply click to the run. So now I can get the false color composite in here. So this is our true color. You can see this is the two band will be added here, true color and false color. So here you can get the false color composite. You can see we can get the false color composite and true color composite. Okay, okay, and you can easily create all of the composite what you need. Okay, just you can use the band combination. Okay, here I use the false color composite, so that's why I simply use here this combination. And if you need the another combination, then you can just change the combination and you can easily get this result. Suppose you want to work with the, so I also try to show you the band combination. Suppose this band combination, I simply search here the Sentinel Q band combination. Okay, so here you can get the Sentinel 2 band combination, and here you can get all of the possibility of all of the resolution, and also get here the all of the band combination. Here you can see natural color. So this is the B4, B3 and B2. This is the natural band combination. This you can see this is the false color composite. Okay, color infrared. So here you can I can get this image like this. This is a short wave infrared. So when you use this band combination, then you can get short wave infrared. Okay, and you can also see this is the agriculture. Suppose you want to identify some agriculture area in your land cover classification. Okay, then when you use the band combination, you can easily identify the some agriculture feature in your area of interest. Okay, you can also see this is the geology. Okay, so when you work with the band combination, then you can easily identify the geological feature. Okay, when you want to work with this band combination, then bathymetric. Okay, you can also see here the vegetation indices. So this is our NDVI. Okay, so when you want to identify the NDVI, then you need to just put your equation. Okay, and you can see in this time when you want to create this the bathymetric, then geology, then agriculture, you don't need to add any equation. Okay, just you can put your combination. Just put your combination in here. Just put this combination in here. Just put this combination in here. Then you can get all of the agriculture feature, then short wave infrared, then false color, true color composite, all of the things we can get. But when you want to move the vegetation index, you can see vegetation index, then you need to work with this formula or equation. Okay, so this equation is that you can see this is the near infrared band, subtract with red band, and division with near infrared band, addition with the red band. Okay, so now you can see this is our vegetation index so formula. So now we can want to work with this formula and also get the NDVI. Okay, and then you can see this is the moisture index formula. Okay, so when you want to work with this, so then you can easily identify the moisture in your place. Okay, so okay, so let's see. So now I also try to show you this the perform, how you can easily calculate this equation, and I already show you that. You can see you can put your equation directly. If you want, you can just put your equation directly, or if you want, you can just use the expression function. Okay, if you want, you can also use the function. Okay, so we can easily calculate it all of the equation, just NDVI, NDWI, or whatever. Okay, all of the indices we can easily calculate it using the this way. Okay, so now I also try to show you that. Okay, suppose I want to work with the vegetation index. Okay, so for I want to calculate it, the vegetation index. Suppose, so for this, first of all, in this time, first of all, I use here the Drake equation. Okay, Drake equation. So Drake equation is that when you work with the NDVI, our equation is that this equation is the B8 band, near infrared band, minus B4, this is a red band, and division with sum of the two band, B8 plus B4. Okay, so now I want to use here the Drake equation. So for this, you can see here, first of all, you can see when I work with this, you can get this result. I simply use here the print, and I want to get all of the information about the image collection. So I simply click to the run. Here you can see there are the total 16 bands. Okay, there are the total 16 bands will be available in this collection. Okay, but in this time I want to work with this this only for the two band, B8 and B4. Okay, so first of all we need to select our specific band. Okay, so first of all I simply select my band, which band I need. So I use a variable and give this variable name is that, suppose use here the red. Okay, and I simply call my equation name is that you can see this is my collection name. So I simply copy this collection name is the selection. I simply call this variable and just paste here. After this I simply, you can see this selection, this variable included total 16 bands. You can see total 16 bands. From the 16 bands I need only for the two band. Okay, so first band is the red band and second band is need for the near infrared band. Okay, I need here the B8 and B4. Okay, so I simply use the selection. This is my whole collection, and then I simply use here the select function. Okay, I simply use here the select function, and in here I just put my band name. So in this time my band name is, my red band name is the, you can simply check what's the red band name. You can see red band name is the B4. Okay, this name is the B4. So I simply use here the B4. I simply use here the B4. Okay, so I select my red band, then I simply use here the another variable is the near. Okay, then I simply call my selection. Okay, this is my whole collection. I simply use here the selection, and then I simply use here the select function. After this I simply select the another band is the near infrared band, and near infrared band is that, you can see the near infrared band is that B8. You can see near infrared band is the B8. So I simply select the near infrared band is the B8. I simply use here the B8. Okay, so now you can see I want to put here the Drake equation. Okay, so this is our one way to calculate the indices. Okay, so if you want, you can simply use here the, I take a variable, suppose this variable name is the NDVI. Okay, after this I use here the Drake equation. Okay, so my equation is that you can see my equation is that near. Okay, this is my near. So near band I simply call the near. Okay, this near, it will be subtract, okay, with my red band. Okay, after this it will be divide, sum of the two bands. So near plus red or near plus red, I simply use here the near, then use here the add function, and then simply put here the red. Okay, so now I can get from here the NDVI, you can see, and it will be stored under this variable. Okay, so now I simply use this variable is that, so I simply, you can see I want to use here the map dot add layer. So I simply show the result in my map interactive view. I simply copy this NDVI, this is my object name, and then suppose I want to get the result, I want to make the visualization parameter. So I simply use here, make the dictionary, and then I just put here the mean NDVI. It will be start from the 0, and max pixel value I want to show in here the up to plus 1. Okay, and then I simply use here the layer name is the NDVI. Okay, so then I simply click to the run. You can get the pixel value between from 0 to up to plus 1. So you can get, this is the another layer is that. Okay, so now we can get the result for NDVI. Okay, in here. Okay, it will be appeared. So here you can see there is a total 3 layer: NDVI, false color, and true color composite. Okay, of this here. If you want, you can also export this map as a TIFF format and work with the art map of QGIS software. It's also possible in here. Okay, so you can see this is the one way for using the Drake equation. Okay, if you want, you can also use the second way is called the expression function. So I simply take the another comment is that, so I use here the expression function. Okay, so in this time when you work with the expression function, suppose I take the variable is that, and this variable name is the NDVI, and then I simply use here the call this variable name NDVI. Okay, I use the same variable name, and then I need to call my selection. So here you can see this is my selection. Okay, this is my selection, this is my whole collection of the Sentinel-2 images. So I simply copy and then I simply paste here. After this I simply use here the function is called the expression. I simply use here the expression function. Okay, and in expression function I just put my expression. What is my expression in this time? My expression is that I simply use here the near. Okay, this near band subtract with red band, and then it will be division with the sum of the two band, near plus red. Okay, then I simply make a dictionary in here. Okay, I make a dictionary, and in this time I just call what is near and what is red. So in this time I simply use here the near. Okay, so near, and then I introduce this near. What is near? So near, you can see I already defined this band V8. So this is the near. So you can see this near, it stored the B8, okay, or near band. Okay, it will be stored. So I simply copy the near and paste here. After this, what is red? So I simply use here the red and define what is red. Okay, red is the, you can see here I already defined the red is the B4. It will be stored the this red. Okay, I simply copy this variable and paste here. Okay, so now you can see I use the expression and make the NDVI. So now I want to show this result. So I simply copy this same variable, okay, and paste here, and I also commenting this line so that it will be not executed. Okay, and then click to the run, so I can get the same result. Okay, I also commenting these things, then click to the run. So now I can get the same result, you can see, but in this time here I use the expression function. Okay, so this is our second way. Okay, we can get the same result, you can see. And our third way is that if you want, you can also use here the build-up function. Okay, build-up function is that it called the normalized difference function. Okay, we can use here in this time. I simply use here the function, and this function name is that I simply put this function name is that normalized difference. Okay, normalized difference function. I use this function and calculated the NDVI indices. Okay, so I simply use the variable name is that NDVI. Okay, I use the same variable name NDVI. Okay, then I just simply call my equation. So in this time my collection, you can see my collection is that, you can see this collection is that selection. Okay, so in this selection you can see this image included total 16 bands. Okay, this image included the total 16 bands, but in this time I work only for the two bands, okay, red and near infrared, only for the two band, because I want to identify the vegetation. Okay, so I simply copy this, okay, collection, and then I just paste here. After this I simply use a function, it's called the normalized difference. Normalized difference. So this is the normalized difference. So in this time I want to get the normalized difference only for the two band. Okay, my band is the B8 and B4. Okay, so I simply use here, you can see this argument is that band name. Okay, so now you can just put here the band name. So I want to make the normalized difference between the two band B8 and B4. Okay, so for this I make a list. I simply use here the square bracket, and then simply put here my band name. First band name is that I simply put here the near infrared, it is the B8, and I also put here the another band is the B4. Okay, and then I simply show this result. I simply use here the same way. So I simply use here the map dot add layer, and after this I simply call this object NDVI. Okay, and then I simply use here the suppose mean pixel value for the NDVI, it will be start from the 0 and max pixel value up to +1. Okay, so that I can get all of the vegetation between 0 to 1, and I want to add here the layer name. Okay, suppose I simply use here this layer name is that NDVI. Okay, and I also just commenting this line, so it will be not executed. Okay, so I simply commenting this all of this line. Okay, so now it will be commenting. Okay, so now I simply click to the run, I can get the same result. Okay, okay, we can get the same result in the NDVI. Okay, you can see this map is not colorful because you can see I only add here the pixel value up to 0, it will be start from the 0 and up to +1. Okay, but I did not add any visualization parameter. So if you want, you can also do this. So I simply use here the plated function, and then I make a list. Okay, suppose I simply use here the red. Okay, then I simply put here the yellow, and then I simply put here the another color is the green. Okay, okay, so you can see here I just set this value. Suppose which pixel value will be 0, okay, then it will be showing the red color. Okay, and then which pixel value is bigger than 0 but less than 1, it's showing the yellow, and which pixel value will be 1 or closer to the 1, it will be showing the green color. Okay, I simply use the color band in here. So now I simply click to the run. So you can see there is the very less vegetation in here. Okay, here the lot of you can see this is the urban area, it's the red color, so there is the no vegetation. And you can also see this is the water, and water is not vegetation, so that's why it will be look like this. Okay, suppose I want to change the visualization. Suppose I want to get here the -1, okay, then up to +1. I want to show this visualization, then simply click to the run. So now I am to show this result between -1 to +1. Okay, so now we can see some visualization parameter. We can get this easily, identify some vegetation or green pixel value. So green pixel, it identify the vegetation. Okay, other you can see yellow, and you can also see some yellow, it not identify water and urban. Suppose I want to check the value from here, I simply click on the inspector, and when I click on the water part, I can get the negative result. So you can see this result is the negative. You can get this result, you can see this is the negative result. So negative result, it means that there is the no vegetation. Okay, it can be water or built up area or barren land. Okay, there is the no vegetation. If you I want to simply click on the green pixel, you can get here the positive result. So it means that there is the vegetation. You can see I can get the positive value. Okay, so it means that there is the vegetation. Okay, I hope you understand this. So if you have any question, you can ask me any question in this time.
And here in the layers, which one we have to open, the natural color or the false color?
Okay, so layer means that you can see, if you want, you can also export this map as a TIFF format. Okay, so if you want, you can also use the map, export this map as a TIFF format and work with the ArcMap and other software, so that you can easily make the map layout and you can use the any color. Okay,
No, at this time we open both false color and natural color. So which one we have to? Both we need to open. Yes, here.
okay, so you can see in this time here I add that only for the 3 map add layer. Okay, so if you want, you can see I use the same variable, so that's why I simply use the okay, I also try to show you this part. Suppose I want to use here, I want to show this result, and I also give the variable name is the NDVI 1. Okay, and I also use here this, and in this time this is the NDVI 1. I simply use here the NDVI 1. Okay, and then I also put here this layer name is the NDVI 1. Okay, and I also use the expression. Suppose I simply so it will be, I think I would delete it. So I simply use here the name. So I use here the expression. Suppose this is the NDVI. Suppose this variable name is the 2. Okay, I simply use the 2, and then I simply call my selection. Okay, I want to use the expression function, and I simply paste here, and then I simply use here the expression function. Okay, and after this I just put here my expression is that near. Okay, near minus red. Okay, I use here the parenthesis, so I simply use here the near minus red, and it will be division with the near plus red. Okay, and then I also make a dictionary, so I simply use a curly bracket. I make a dictionary in here. I make a dictionary, and then I simply put here the, suppose this near. What is near? Near is that it come from this variable. So same, so I simply copy this name and paste here. Okay, this is my near band. And what is red? I simply put here the red. Okay, then identify what is red. So I simply put here the red, and then simply call this red band. Okay, and paste here. Okay, so you can see in this time I also show this layer. So I simply call the NDVI 2. I simply copy and then paste here. Okay, and all of the okay. So I simply click to the run. So you can see in this time all of the layer, you can see NDVI 1, NDVI, okay, all of the layer will be available in here. So I also put here this the NDVI 2. Okay, okay, suppose you want to change the visualization for the pixel value. Suppose for the NDVI 1 I want to get this result from 0 from up to 0.5. I simply use here the 0.5. Okay, so then I can get these images only for the pixel value up to 0 to 0.5. Okay, suppose in this time I also use here the point. Suppose I want to get this result from the 0.5 to 1. Okay, so I simply use a 0.5 to 1. Then I can get this pixel value for the you can see NDVI 2 layer. I can get this pixel value. It will be start from the 0.5 and up to 1. Okay, so I simply click to the run. So you can see this is the all of the layer true color composite. It will be showing in here. Then it will be showing the false color composite. Then it will be showing the NDVI 1. Okay, which I select the pixel value. This is the another, you can see it will be showing the another pixel value. Okay, which I showing here. Okay, okay, actually it means that which pixel value I set here, between this pixel value will be stay, it will be showing. Okay, like this. Okay, and this is the common way for calculating all of the indices. We can calculate any indices using this way. Okay, we can calculate any indices like this way, and you can also see here the NDWI, NDVI, or all of the indices for the vegetation indices or the moisture index. Actually, what's index you need? Okay, just you weigh the same procedure. Okay, then if you want, you can also export this map as a TIFF format and work with the ArcMap or QGIS software. Okay, I hope you understand this part. Any question in here?
Which value we need to put here for the significant result, like from 0 minus 1
Okay,
to 1?
so it is the different type of NDVI classification. Okay, so I also try to show you that. Okay, suppose NDVI classification. Okay, so simply click on the image. So here you can see NDVI range between -1 from 0. Okay, between this range I can get this feature: water, snow, or cloud. Okay, between the point 0 from point 2 I can get the barren land build up. Okay, or rock. Okay, you can also see point 2 from up to 1 I can get the vegetation. Okay, so here you can see there are the different types of paper. They are already work with the NDVI range. Okay, so every NDVI range will be provide you the every each feature. Okay, so here you can see this is the another way. Okay, so you can see dense vegetation. So dense vegetation 0.5. Okay, intermediate green vegetation 0.1. Sparse vegetation you can see 0.09. Okay, bare soil 0.025, cloud 0.002, snow and ice negative 0.046. Okay, water surface you can see point. So here are the different types of range, and we can easily, using the different types of range, we can easily identify different types of feature. Okay, any question in here?
Sir.
Okay,
And also I have to ask these in different, like say Landsat, OLI, and TM. In different, the NDVI formula is different. Not only NDVI but vegetation indices.
actually it's depend. You can see here in this time actually NDVI formula is the same, but it will be changed when you with the band. Suppose NDVI formula, we can know that NDVI formula is that, you can see NDVI, this is the formula. Yes. Is that near infrared band minus red band. Okay, I simply use here the near infrared band plus red minus red band division with near plus red. Yes. Okay, so this is my formula, and you can see here in this time what is your near band for the Sentinel-2. So here you can see this formula is the same, but you can see this band name for the near, you can see B8. Okay, but Landsat image, when you want to Landsat image, then you can see this near band name is the B5. Okay, and you can see this is the B4, it represented the red band. Okay, so formula is the same, but it will be changed when you work with the band. Okay, so band actually Sentinel band and Landsat band is not same name. Okay, so it will be some just you can put this name, but you can see we use the same formula, near and red. So suppose you want to check what's the band name in the Landsat, I simply search at the Landsat. Suppose top of atmospheric. Okay, so I simply go to the browse data catalog. So in this time here the networking issue, so that's why this search option is not good. Okay, so I simply Okay, so it will be appear, right? So data catalog, I simply open the Landsat. Okay, so here I can get all of the Landsat collection. Suppose I want to work with this Landsat 8 top-up atmospheric, this dataset. I simply click to here. I can get all of the information about this dataset. You can see this is the bands. Okay, here you can see for the NDVI we use here the near infrared band and red band. So this formula is the same, but you can see this band name is not same. Okay, this is the V4 and this is the V5. This is the red band V4 and here the near infrared band is the V5. Okay, so when you work with this data set, then you need to use here the V4 and V5, but when you work with the Sentinel, then you need to work with the V4 and V8. Okay, so just you can find out the formula, then move to the your image collection with what image you use here, then you can find your band name, then you can just put this equation. Okay, I hope you got this point. Any question?
And one more thing is like how to extract its values. Like how can I?
So if you want, we can you can see this image. If you want, you can also make this as a TIFF format. Okay, so if you want, you can also extract this map as a TIFF format, and you can easily work with the ArcMap software and extract the value. Okay, so I also try to show you that. Suppose I want to export this map. So I simply use here the export function. And here I can get all of the argument one by one, and in this time I just make a dictionary and put all of the argument one by one.